Hello grade 9 students! Welcome to our math video lesson. I am your math teacher Justine and I will help you today understand your Q3 week 2 module. Please prepare your math module, math notebook and your pen so you can follow through our lesson. Are you ready? Let's start!
Hello students! We will be learning today about Midline Theorem, trapezoids, and kites. And for the learning competency, at the end of the video lesson, you will be able to solve problems involving Midline Theorem, trapezoids, and kites. What a beautiful lake! Given the diagram, what is the distance across the lake? In order for us to solve the problem, we need to have the knowledge about midline theorem. The midline, which is sometimes called the mid-segment, is a segment joining the midpoints of the two sides of a triangle. In triangle ABC, D is the midpoint of side AB, while E is the midpoint of side AC. Therefore, the segment DE is the midline of triangle ABC. The midline theorem. The midline is parallel to the third side and half as long. Since segment DE is a midline, thus segment DE is parallel to segment BC, and DE is equal to 1/2 the length of BC, or BC is twice the length of DE. Going back to the problem, what is the distance across the lake? We know that the distance across the lake is a midline because it is a segment joining the midpoints of the two sides of our triangle. So we will apply the midline theorem. For our solution, the distance across the lake will be equal to half the length of the side parallel to it. So the side parallel of the distance across the lake is the side having the length 7 kilometers. So that is equivalent to 1/2 times 7 kilometers. And 1/2 of 7 is 3.5 kilometers. Therefore, the distance across the lake is 3.5 kilometers. For the next example, in triangle ABC, the points A and B are midpoints. Find the value of x and AB. So we are given that segment AB is a midline. Thus, by midline theorem, segment AB is parallel to segment XZ. We are also given that AB is equivalent to 3x minus 1 and XZ is 34. So solving for AB, we know that AB is half the length of XZ. So XZ is 34. We will substitute 34 to XZ. So AB is equivalent to 1/2 times 34. So 1/2 of 34 is 17. Therefore, AB is 17 units. To solve for x, we will apply the value of 17 for AB. So by equation, 3x minus 1 is equal to 17. So to isolate 3x, we will transfer -1 to the right side of our equation. So that is 3x equals 17 plus 1. So simplifying, that is 3x equals 18. And we will divide both sides by 3. So x is equal to 6. Therefore, x is 6 units.
Now let's proceed to trapezoid.
Trapezoid is a convex quadrilateral with exactly one pair of parallel sides. The bases of a trapezoid are the two parallel sides, while the legs of a trapezoid are the two non-parallel sides. The pair of angles that share the same base are called the base angles. In trapezoid EFGH, Segment HG and segment EF are the bases, and segment HG and GF are the legs. Angle E and angle F are the base angles, sharing the same base EF, while angle G and angle H are the base angles, sharing the same base HG. The median of a trapezoid. The median of the trapezoid is a segment that joins the midpoints of the legs. Using the same trapezoid EFGH, notice that point I is the midpoint of the side HE, while point J is the midpoint of the side GF. Thus, the segment IJ is a median of the trapezoid EFGH. Theorem 1. The median of a trapezoid is parallel to each base, and its length is 1/2 the sum of the lengths of the bases. If IJ is the median of the trapezoid EFGH, then the length of IJ is equivalent to the sum of the bases HG and EF all over 2. So for the first problem, if IJ is equal to x, HJ is 8, and EF is 12, what is the value of x? So we are given that IJ is equal to x and it's the median. So HJ is 8 and EF is 12. So we are asked to find the value of x, which is the length of the median IJ. So since it's the median, by theorem 1, to find the value of x is just to add the bases of the trapezoid, the HJ and EF, and after we get the sum, then we will divide it by 2. So adding the length of the bases, we have 8 plus 12 all over 2, so that is 20 divided by 2 is equivalent to 10. Therefore, the value of x is 10. An isosceles trapezoid is a trapezoid with congruent legs. Theorem number 2. The base angles of an isosceles trapezoid are congruent. Theorem number 3. The opposite angles of an isosceles trapezoid are supplementary, or it will add up to 180 degrees. For example, 129 degrees and 51 degrees are opposite angles, and if we add them, their result will be 180 degrees. Theorem number 4. The diagonals of an isosceles trapezoid are congruent. So in this case, diagonal 1 is equivalent to diagonal number 2. For this example, the figure is an isosceles trapezoid ABCD with angle A and angle B as base angles. If measure angle A is x plus 20 and measure angle B is 2x, find measure angle A. Remember that by theorem number 2, base angles of an isosceles trapezoid are congruent. Hence, angle A is congruent to angle B. That is, measure angle A is equivalent to measure angle B. So we are given that measure angle A is equivalent to x plus 20 and measure angle B is 2x. So we have to find the measurement of angle A. So since we know that measure angle A is equivalent to measure angle B, then we can equate their measurements. So that is x plus 20 is equal to 2x. Then we will transfer 20 to the right side of our equation and negative 2x to the left side. So simplifying it, we got negative x is equal to negative 20. Then we will divide both sides by negative 1. So x is equal to 20. So we will substitute 20 for x in measure angle A equals x plus 20. Then we will solve it. So substituting 20, so 20 plus 20. So measure angle A is equal to 40. Therefore, the measure of angle A is 40 degrees. Finally, let's proceed to kite. I know you like kites. So what is a kite? A kite is a quadrilateral with exactly 2 distinct pairs of adjacent congruent sides. Number 5. The diagonals of a kite are perpendicular to each other. It means that all the four angles formed by the diagonals each measure 90 degrees. Theorem number 6. The area of a kite is half the product of the lengths of its diagonals. That is, d sub 1 times d sub 2 all over 2, where d sub 1 and d sub 2 are the diagonals. So let's have these examples on kites. In this figure, name pairs of congruent and adjacent sides. I'll give you 10 seconds to do it. So time is up. So here's the list of congruent sides and adjacent sides. So can you count how many correct pairs you've got there? So using the same figure, the next question would be, if LM is equal to 6, what is MN? For solution, since LM and MN are congruent sides, then MN is equal to 6. For our last example, if Ln is equal to 7 centimeters and Km is equal to 13 centimeters, what is the area? So we are given the length of our diagonals. We know that by theorem number 6, the area of the kite is equal to the product of the diagonals, all over 2. So area of the kite is equal to 7 times 13 divided by 2, and that is 91 divided by 2, which is equivalent to 45.5. Therefore, the area of the kite is 45.5 square centimeters.
If you have questions about our lesson today, you can always message me through my messenger. Thanks for watching, students. Enjoy answering your modules. God bless.